Hello Doctor, I'm Ravin, and for this lab I will be showing you how to write the mnemonical table codes for the PLC ladder diagram. So as you guys can see, for the first diagram you have two of this which we call conditions, and this is the output. So these are the condition which we call normally open. As you guys can see, it's normally open. And so to write the address, first we start with the binary 00000, and then we instruct the first instruction, which means LD ladder diagram, which is 001. And then in address 001, as you guys can see, this is an AND gate combination of the both normally open conditions. So this is what we call an AND gate, or in a logic gate base is N. So we instruct it is as an AND gate, and the data is 0002, and finally we will have the output at address 0002. It is called output, which the data is 10000. So we go for the next one, which is data 7.12. As you guys can see, this is the same logic gate, but this one has a normally open condition and a normally closed condition, which means, for example, when supply is traveling, when the switch is off, that means supply is traveling at the normally closed condition, means supply is going through here to the output. So when we press the switch or on supply, this will open and this will close. So the supply from here will be cut off and the supply from here will go on. That's what it means by a normal open condition and normally closed condition. So as you guys can see, the mnemonical code table at address 0001 is the LD, and the data is 0005, and the next one is an OR NOT. OR NOT is a logic gate, where the condition, you can also refer the truth table for a NOT or NOR gate, which will be similar to this ladder diagram. So OR NOT at the data is 0008, and lastly at 0002 the output is 10007. And then for the third one, as you guys can see, this is a bigger diagram, so it's a bit difficult to derive, and we start off with the same one where LD is 0004, and then the data is 004, and then you guys can see this and this together, we call it an AND NOT gate. And then at 0001 it's an AND NOT, and the data is 0006. Then we continue with an AND gate. So as you guys can see, to 00, this two is, you combine these two, and then with this it's an AND to this, right? So we call it an AND gate, and it's a point of 0008. Next up, we restart from LD, because this is one condition and this is another condition. LD again, and then this is an AND gate, and there you go. Then this two is to an OR LD, so we write this as OR LD because it's one is above and one is below. And then finally the output will be at 010011, and that's how it goes for every single logic gate. Thank you for this, and my partner will be talking about the next section. Thank you.
Hi, Dr. My name is Shun Yao Xuan. So now I will continue to do the presentations for the another part, for one of the part of the lab 5, which is Mrib Lab 1. For my part, I will present is what happened to output of each problem when you run a program and test output according to input given. Using truth table means that how I can build a truth table from the diagram given. Actually, this is very easy because you can see that for example, it's 7.1.1. Before we do the extract the truth table, we have to extract the function first, which is 00001 AND gate 0002. So it means that between them have an AND gate. So for here, we can look here. When you put 00, it will be 0. 01 will be 0. 10 will be 0. 11 will be 1, because this is an AND gate. AND gate, which means it's multiple. So 0 multiple 0, 0. 0 multiple 1, 0. 1 multiple 0, 0. 1 multiple 1, 1. And for the 7.1.2, this is in a parallel, which means that that is an OR gate. But at the 0008 contact, it has a NOT gate. So it is also simple like this one. 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1. It seems that why it is become 1. A true is 0, 0, because in the context 008 has a NOT gate. So 0, NOT gate 0, 1 equal to 1. 0, NOT gate 1 equal to 0, 0, 0. 1, 1, 1. 1 plus 1, 1. So this is the answer. So for the Z1.1.3 will be more difficult and longer since that it had a 5 contact. So from here we can see that 0.000004, 0006, 0008 has 2 AND gate between them. And 0000 have an AND gate between 00001. So after the 2 AND gate had to be add together with an OR gate, the output will be obtained. So the output will be like this. Actually, for this output is longer than 10 slot. If this is, I think it's 30 something slot, but doctor wants us to only write 10 slot. So this is a 10 slot with 5 slot that the output will be 0 and 5 slot the output will be 1. So for the Z1.1.4 will be more troublesome and more difficult because he has 7 contact. Actually, it's easy because first of all, we can just 00014 add for an AND gate for 006 between one new contact first. Then you only use an OR gate to compose these two contact become 1. Here also the same 0001 AND gate 0003 one new gate. So 0006 0008 OR gate 000 new gate here. So they will become 2 new AND gate, 2 new OR gate. So an AND gate is between 2 new OR gate. Will be a new AND gate here. So to get the final output here, it is a parallel. So we have to use another OR gate. So the new OR gate here, new AND gate here, to combine with 0007 with an OR gate, and output will be here. So for this is the truth table that I have to build from the equation I get. Actually, this is more longer than before that. Before that is 30 something slot. For this one is above 60 slot. So it's also choose 10 slot, which 5 slot is the output is 0 and 5 slot, the output will be 1. So for the last example, last question is 7.1.5. From this picture, see that it is difficult, but this is easier than previous because here I have 3 output, which means that we can see it separately. From output number 1 and number 2 here, you can see that that is 006, 008 AND gate, 000, 000 AND gate, 001. So they will have a 2 new gate here with an OR gate. So after that, you have to 004 AND gate with the new OR gate here, we will get the result for 10011 and 10012. These 2 output will be the same since that the 2 equation is same. And for the 10010 output, this is another one because there's no connector with here, which means that 0003 if a NOT gate, AND gate 0005. And this is the truth table. This one is the first part, which the output is 10011 and 10012. It's also 10 of the example and here is the second part, which is 003 and 0005. Output is 10010. This is only have 4 outputs since they have only 2 contact. And actually, after we do all this, we have do all this value, we can do a double checks for our truth table value is whether it is correct or not by enter the function that we have built into an online system, any online system provided. Then they will compile it automatically the truth table, so we can double confirm that whether the truth table we do that is correct or wrong. So that's all for my part. For the next part will be which is the question and the conclusion will be presented by another group members. Thank you.
Okay, so for question 7.2, what happens to lamp 10011, 10012, and 10010 when contact 0.0004 is broken? Is that those lamps won't turn on since the contact is broken. Therefore, it will be in off condition when supply is inserted or when you start the program. And as for the LAM 10010, it will always on due to contact 00003 being normally closed condition. For question 7.3, what is the function of find 0001 using the console, and what will happen if this function is not included? So if this function is not included in the program cannot be implemented as it is the last instruction required for completion of the program. For the discussion, so PLC programming can be done in a variety of methods, including the mnemonic or ladder diagram. So despite the fact that the procedures are different, the results are the same for both methods. And we are able to understand the flow of the ladder diagram and how to program the PLC on one kinetic using the control pad through the use of mnemonic code after reviewing the results obtained from the experiment conducted and the steps on using the console pad, also known as the programming device, because these are the most fundamental on how to understand the concept of the PLC. However, since the programs rely on the ladder diagram, user may misunderstand the ladder diagrams too because the symbols used in the ladder diagram represent logic gates. Regardless of this potential, we can avoid making this mistake by learning the foundations of logic gates. So as for the conclusion, based on the experiment, we can conclude that the PLC executes commands from user programs created by the client one at a time, reading and writing data in the internal PLC memory region simultaneously. Data package from sensors or switches directly linked to the basic input-output unit are swapped with data in the PLC internal input-output memory as predetermined periods. So the input-output refresh operation also refers to the process of completely exchanging external data and the internal input and output memory data. That's all from us. Thank you.